Hello and salam sejahtera to everyone, and to our lecturer Dr. Nabila binti Sabarni. My group member will present a case study about twisted beam at private school in Johor Bahru. My group member consists of Jackie G. Senken and myself Zen Sivito Madang Anak John. First of all, I will present about the introduction. As we know, every year we are struck with the news of construction failure from minor and major causes due to structural failure such as crack wall, beam failure and other defects, and lead to major catastrophic collapse. We also know buildings are designed to support certain load without deforming excessively. The load are the weight of people and objects, the pressure of life load and dead load of the building itself. In the case study, the building is a classroom of a private school in Johor Bahru. From the visual inspection, the beam were twisted like snake, and the structure is the beam, and it was constructed using steel, and found that the beam was failure. An ad hoc meeting was held and come to decision that a team of consultants will appoint to investigate the matter and eventually justify the solution. As a consultant team and investigation team, the first thing we do is doing visual investigation on the building. Firstly, we use Jabatan Kejaraya Building Visual Inspection Form. The form is called Borang Kondisi Bangunan Laporan Pemeriksaan Visual Komponen Bangunan. The visual inspection has conducted and few component and data was taken during the inspection, and the causes of defect is identified. As we can see on the slide, they are the form that we use to do the visual inspection. From the visual inspection, the beam was twisted and it one of type of beam failure for building. The twisted beam, basically known as torsion or twisting moment. It happened because when the load not acting at the central, the longitudinal axis of the beam, then it would try to twist the beam about its transverse axis. The force within the flank not only causes the beam to defect but also to twist the longitudinal axis of the beam. The resistance to twisting of the beam section is depend on the torsional resistance of the beam section. There are mainly three main factors that influence the lateral torsion buckling in beam are location of the load applied, the shape of bending moment applied, and end support. I will explain more on the three main factors that influence the lateral buckling that I explained just now. First, location of the load applied. The location of the load applied is the susceptibility of the beam section to the effect of lateral torsion buckling is governed by the distance between the location of the load applied and the shear center of the section. The section is more prone to lateral torsion buckling if the load is applied on the point above the shear center of the section. The effect is less if the load applied is along the shear center. Second, the shape of bending moment applied. The shape of bending moment applied is a section with uniform bending moment along the length has less buckling resistance compared with the section subject to different bending moment distribution. Lastly, end support condition. When the end support of the beam section are more resistant, increase the buckling resistance. At end support that offer less restraint have a decreasing buckling resistance. I will explain more on the recommendation method to avoid torsion of beam. As I mentioned just now, firstly, increase the thickness of beam and plate. By increasing the thickness of plate and beam, we increase torsional stiffness. This comes at a large wage penalty, so use this sparingly. Larger shear stress on a flat beam will occur at the center of longer side. Stiffness increase will increasing of the beam thickness, and stiffness double as increasing in thickness with 0.1 fm. The effect of thickness on stiffness is far greater than that of blank holding force. The greater the arch height of punch, the greater the stiffness. Second, by applying braces to open section, a beam that relies on adjacent structure member for support is braced in a lean on a system. Structural members that are tight or linked together, such that buckling of the member would require adjacent member to buckle with the same lateral displacement characterized lean on. The bracing is to provide stability and resist lateral loads either from diagonal steel member or from a concrete core. For bracing beam are designed only to support vertical load, since the bracing system should carry all lateral load. Lastly, addition of support for beam. Columns are vertical structure that transmit compressive load. Columns support the floor or roof beam, and the column on the floor above and the bottom floor column must be strong enough to carry the accumulative weight of every floor above it. Load is transferred through the transfer beam to the transporting column, ultimately to the foundation. These columns are designed to take vertical load, considering it a compression member.
Hello everyone, my name is Jackie. For now, I will present about structural design and analysis check. The secondary beam are assessed 3-phase multiple 171 multiple 51 UKB section with a steel grade of S275. The section property as shown below. The critical bending moment of the cross-section that caused the failure of the beam can be determined using the following equation, where C1 is equal to 1.88. This critical moment can be assumed to be equal to the design resistance of the cross-section. Using this equation, we get 37.6 kN for critical bending moment. The beam span is 10 meter and is designed to carry a uniformly distributed design load 12 kN per meter square. We are using moment distribution method to determine the final bending moment in the beam. After that, we go through the following steps, such as to get the total dead load, stiffness, distribution factor, and fixed end moment. At last, we get 750 kN for the final bending moment. Item number 4 is regarding building law and safety and health. Building law are the rules and regulations implemented by the government and local authority should be followed, where rules and regulations have to be formulated while constructing and maintaining wall building. Below are the rules and regulations must be compliant. Street drainage and building at 1974 at 133. Number 1. Part 5 building number 83. Power as regard building in ruinous and dangerous state. Number 2. Part 5 building number 85A periodical inspection of building. Stakeholder also can penalty the building owner due to improper periodical inspection by the professional engineer registered under the Register of Engineer at 1967. 4.2 Safety and health. Before commencement of any renovation work, owner of the building and contractor of the project had to follow the guideline given by OSHA. The reason that we have to follow OSHA guideline is to, number 1, avoid risk where possible. Number 2, evaluate risks that cannot be avoided. Item number 3, put in proportion measures that control them at source. Number 4, appointing the right organization and people at the right time. Implementation of the regulation is extremely important for regulatory efficiency. Legislation or regulation is guideline for controlling activity.
And for our conclusion, bad design, poor construction, foundation failure, optional load, and anticipated failure mode, and a mix of causes are major causes of structure failure. Below is the conclusion that we assume that may affect the failure of structure. First, inspection. For inspection, a regular inspection of building by expert engineer for structural degradation of fault should be made mandatory every 5 years, and buildings that are subjected to such mandated inspection should be inspected more frequently. For design of structure, the structure design of the structure is the root and primary causes of the structure failure. The dead weight of numerous structure elements were underestimated, and a substantial number of individual structure members were grossly underdesigned according to structure analysis. Third, additional offloading. Through the building lifespan, decisions were made and even occurred that exacerbated the awful position it was already in. Significant load not included in the structure design were added to the structure, causing the already overloaded and poorly designed structure to the loaded even more. As conclusion for our case study, our group member were made a decision that we assume two numbers of column by 3.33 meter interval is suitable to support the beam to distribute the excess load from the beam to the column. That's all for our presentation. Thank you for listening.